We're going to talk about finding rational and real zeros. First example, we're given p of x equals x minus 1, x plus 2, x minus 3, and x plus 4. So what we're going to do, we're just going to set this p of x equal to 0. So say x minus 1, x plus 2, x minus 3, and x plus 4 equals 0. So what we're going to do is we're going to set each piece equal to 0. We're going to say x minus 1 equals 0, add 1, add 1, we're going to get x equals positive 1. We're going to set x plus 2 equals 0, subtract 2, subtract 2, and we'll have x equals negative 2. We'll have x minus 3 equals 0, add 3, and we'll have x equals positive 3. And last we'll have x plus 4 equals 0, subtract 4, subtract 4, we'll have x equals negative 4. So our zeros are x equals 1, negative 2, 3, and negative 4, and we're done. Example 2. A polynomial p has zeros at x equals negative 4, x equals 3, and x equals 1/8. What could be a value? What could be an equation of p? So if we know x has a 0 at negative 4, we have to think x plus 4, because we want to think opposites. We think about zeros, just like we did in the last problem where we had to solve. We want to think opposites. So for this 0, we're going to have x minus 3. Remember, this is the polynomial px. Our problems will be x equals 1/8. So if we're dealing with 1/8, so we have 1/8 x, or let's write it like this: x minus 1/8 equals 0. But we typically don't see it written as a fraction, so we're going to multiply by the common denominator, which is 8. So it's going to be 8x minus 1 equals 0. And if we solve that, we will get 1/8. So our polynomial p is going to be x plus 4, x minus 3, and 8x minus 1, and we are done. Example 3. What could be the equation of p? So we have this graph here. We have a 0 at negative 4. We have a 0 that looks to be about 1/2, so we can say that's x equals 3/2, because 1.5 is equal to 3/2. And we have another 0 at x equals 3. So the easy ones to handle are going to be the x equals negative 4. So we just rewrite that as x plus 4. The other easy 0 to handle is going to be x equals 3. Change it to x minus 3. Just think opposites. The tricky one is going to be the x equals 3/2. So we can write that like we did in the last one. X minus 3/2 equals 0. Multiply everything by 2. So we'd end up with 2x minus 3. So our final part of our equation would be 2x minus 3. If we look at our options, we have x plus 4, 2x minus 3, and x minus 3. Correct answer should be D, and we are done. Example 4. We have px equals x to the third plus x squared minus 9x minus 9. We're to plot all zeros or x-intercepts of the polynomial on a graph. So first thing we want to do is we want to try to factor it. So we can factor out x squared, and we're left with x plus 1. You factor out a 9. And we're going to be left with x plus 1. So if we multiply this back out, we'd have x cubed plus x squared minus 9x minus 9. We get the same thing. So now we're going to have x squared minus 9 and x plus 1. We can factor this x squared minus 9 a little bit farther to be x plus 3, x minus 3. We have difference of squares, and x plus 1 equals 0. So our zeros are going to be, we have x plus 3 equals 0. We're going to subtract 3 from both sides. That's going to give us x equals negative 3. We have x minus 3 equals 0. Add 3 to both sides. That's going to give us x equals positive 3. And then we have x plus 1 equals 0. Subtracting 1 from both sides, that's going to give us x equals positive 1. Or sorry, negative 1. So our graph should look something like this. We have negative 3, negative 1, and positive 3. So our graph should do something like this. And we can confirm that with technology. So that's going to pass through negative 3, negative 1, and 3. So if we wanted to, we can confirm that with technology. So we're going to go to Desmos, and we'll type in our graph. X up to the third plus x up to 2 minus 9x minus 9. And let's just zoom out just a little bit. Let's fix our window. So negative 10, positive 10, negative 10, positive 10. And that's how our graph looked. If we touch our intercepts, we can see a 0 at negative 3, a 0 at negative 1, and another 0 at positive 3. And the shape is very similar to what we sketched by hand. And we're done example 4. And example 5, we're given p of x equals 5x cubed plus 5x squared minus 30x, and it says plot all zeros or x-intercepts on a graph. So first thing we're going to do, we're going to factor out a 5x. So we have 5x, and we're going to be left with x squared plus x, and then negative 30 divided by 5x is going to be negative 6. So we can factor this guy, x squared minus 6, to be x plus 3, x minus 2. Then we have 5x, and we'll set it equal to 0. So that means we have to set 5x equal to 0. And that's just going to be x equals 0 if we divide both sides by 5. We're going to set x plus 3 equal to 0. We'll subtract 3 from both sides to get x equals negative 3. And then we're going to say x minus 2 equals 0. Add 2 to both sides, and that's going to give us x equals positive 2. So if we try to sketch a graph, we have 1, 2, 3. That would be negative 3. 1, 2, 3, positive 2, and 0. So our graph should do something like this, passing through 0 and positive 2. So let's go to Desmos and confirm our graph and make sure our graph looks something similar using technology. So we're going to go to Desmos, clear out the old graph. So we have 5x up to 3 plus 5x up to 2 minus 30x. And we have a 0 at negative 3, a 0 at 0, and another 0 at 2. And if we zoom out just a little bit, we can see the top and bottom of the graph. And it looks very similar to the sketch I made using freehand. So hopefully this helps you understand how to find zeros of a graph and how to sketch a graph using just the zeros.